So this is the last lecture on the gas chapter, chapter 13, and this is about gas stoichiometry. If you remember that molar volume is 1 mole of a gas at standard temperature and pressure, takes up 22.4 liters. And just to kind of go over that again, why that's true, some people say, well, wait a minute, a big gas has to take up more space than a little gas. Well, remember, here's your big gas. The big gas is big, so it moves slow. Think about pushing a car. You push a car, not so fast. Bicycle, though, is a lot easier to push. Little molecule goes fast, big molecule goes slow. And when they move, the idea is that they take up the same amount of space. Now, the big one is big, so it doesn't have to move as fast. The little one, it's little, but it moves fast. And between those two facts, that means that this molecule takes up the same amount of space as that one. So if that's true for one molecule, if you have the same number in two containers, as long as they're the same temperature and pressure, then they will be equal in the number of particles. And that's Avogadro's principle, which we talked about last time. But that particular value at standard temperature and pressure, 1 mole is 22.4 liters for any gas. So when we talk about stoichiometry, remember that we're using a balanced equation to get our conversion factor. If we're just talking about one gas, then we don't even need the balanced equation. All we're going to use is the 1 mole is 22.4 liters, or 22.4 liters over 1 mole. So it's just a variety of problems. We've done all of them, but it's just a reminder that you may, in this chapter, you're going to see 1 or 2 problems that use gas stoichiometry or use the 1 mole is 22.4 liters. As always, remember that when you do the dimensional analysis, you start with the known over 1 in the first blank, cover the number in the known, drag the units down to the denominator because the units have to cancel, and then you put your unknown units in the top on the numerator of the second blank. That's the rule that we've gone over and over and over, and hopefully by now you know that. If we're doing a stoichiometry problem with a balanced equation, steps are here. Balance the equation, write the known values in the first numerator over 1, write the unknown units in the second numerator, and again you drag the first blank's units down to the denominator of the second blank. All of that's in here step by step, and if you follow those steps, we've already done gas stoichiometry problems, but since we're dealing with gas in this chapter, just kind of a review of some of the stoichiometry. Different types of problems: mole-mole, mole-volume, volume-mole, volume-mass, mass-volume. So these are different types of problems. Let's see, does it have volume-volume? It doesn't. Here's one that's volume-volume, and we'll work through that. How many liters of gaseous water, that's our unknown, so you write unknown in liters, H2O, are produced when 80 liters of oxygen are reacted with excess hydrogen. 80 liters of O2, that's our known. So when we write it, you can see here on the notes, we end up with the 80 liters over 1 in the first blank. So our known is in the first blank, 80.0 liters O2 over 1. 3 blanks. Cover the number, drag the units, liters of O2, and then we put our unknown units here, liters of H2O, and we go look at the balanced equation. So the way we talk about this is draw a bubble. We need liters of H2O and liters of O2. Draw a bubble around the H2O. How many liters are in the bubble? Well, if it's 2 moles, 2 times 22.4. Every mole has 22.4 liters, right? 2 moles has 44.8. So we put 44.8 liters there. And then we look at the bottom, liters of O2. There's 1 mole of O2. We already know 1 mole of a gas at STP is always 22.4. So, if you're like me, you try not to use the calculators unless you have to. 44.8 over 22.4 is 2. 2 times 80, 160. 3 significant digits. We have to put that decimal point there to give it 3 significant digits. 160 liters of H2O. That's one example. If you want or if you need to, you can go back to the stoichiometry chapter on the website, pull up some of the practice problems, work those. Or if you've been good about keeping your papers, go back and look over some of those. We'll have a bunch of practice problems in this chapter. Just check where you pick up your papers, and I'll try to put some of them out on the web. That's it for this last section of notes. Work on your review. Come in tutorials if you need help, and good luck.